Hello, how are you? I hope you are fine. Today we will talk about elements around us. Element element is the simplest form of matter that can't be decomposed into two substances or more. Matter consists of molecules, consists of atoms. Classification of elements. Elements classified according to their properties into metals and non-metals. Metals classified into solid and liquids. Solid metal such as copper, iron, aluminum, gold, and silver. Liquids, the only metal in liquid state is mercury. Non-metals. Non-metals exist in solids, liquids, and gases state. Solids, non-metal, such as carbon, sulfur, and phosphorus. Liquids such as bromine. Gases such as oxygen, nitrogen, and hydrogen. Properties of elements. Metallic cluster, conductivity of electricity, conductivity of heat, melting point, malleability. Metallic cluster means shining. Metals have metallic cluster such as iron, copper, and gold. Non-metals don't have metallic cluster such as carbon and sulfur. Electric conductivity. We need some materials such as electric circuit, some metallic materials, a piece of sulfur, and a tip of a pencil. We connect the metallic material to the circuit and we notice that the electric bulb lights up in case of metallic materials. We repeat the activity using the piece of sulfur and we notice that the bulb doesn't light in the case of sulfur. So metals are good conductor of electricity, non-metal are bad conductor of electricity except carbon. Except carbon. Graphite is a good conductor of electricity. So now we will watch a video to see this activity.
For the pencil resistor project, you will make resistors out of pencils by cutting them to various lengths and then sharpening them on both ends. To connect them to your circuit, use the alligator clips and clip on to the graphite tip on both ends. Make sure you do not connect to the wood and that the metal from the alligator clip actually makes contact with the graphite. You can see that when I do that, the light bulb lights up, much dimmer than it did before when I connected the two alligator clips directly to each other. But again, be careful. You'll see that if I clip on and don't make good contact with the graphite, and I'm only touching the wood, the light bulb will not light up at all, and that will affect the results of your experiment. So make sure the metal from the alligator clip makes good contact with the graphite tip of the pencil. To conduct your experiment, you will make multiple pencils of different lengths and measure how the length of the pencil affects the brightness of the light bulb. For directions for thousands
Heat conductivity. Metals are good conductors of heat. Non-metals are bad conductors of heat. Metals are good conductors of heat and they conduct heat by different degrees. Non-metals are bad conductors of heat. So to improve this, we should do this activity. We need wax, a holder, a group of elements, and a flame. Let's watch this activity.
We have rods of different metals attached to a central hub. On each of the rods is a small amount of butter. The metal rods have different specific heats and will heat up at different rates. We will watch the order in which the butter melts. The aluminum melts first. The brass melts second. The iron melts third. The nickel melts fourth. The copper melts fifth. The stainless steel melts sixth.
Melting points. Metals have high melting points. Non-metals have low melting points. Look at this picture. We have nail, copper wire, a piece of lead, a piece of sulfur, and we have a stand and a flame. Observation. The iron nail, the copper wire, and the piece of lead don't melt, while sulfur melts easily. So, elements differ in their melting points. So, metals have high melting point, while non-metals have low melting points. Malleability. Metals are malleable and ductile. They can be bent and reshaped. Non-metals are not malleable or even ductile. They can be bent. They can't be bent and reshaped. They can't be bent and reshaped. We need some materials to improve that. We need a hammer, some metallic substances, and some non-metal substances, and we use hammer to reshape this materials. Let's see a video to show that activity.
Metals are malleable. In this module, you will learn that metals are malleable. For this activity, we need a small iron nail, a piece of coal, a pencil lead, a piece of thick aluminium wire, and a hammer. To start with, beat the iron nail with a hammer. Hit the nail hard. You have to do it carefully. Take care so that your hands do not get hurt. Now hit the aluminium wire hard. This time also take care of your hand. What do you see? Is there any change in the shape of nail and wire? You can see that the shape of the iron nail and the aluminium wire changed on beating. When they are beaten harder, the iron nail and the aluminium wire take the shape of thin sheets or they are flattened. Now hit hard the gold piece and pencil lead with the hammer. Interestingly, you will find that gold pieces and pencil lead break into small pieces on beating. It is the property of the metals that they take the shape of a thin sheet on being hammered. This property of the metals is known as malleability. This is a characteristic property of metals. As you saw in the experiment, materials like coal and pencil lead do not show this property as they are not metals. In this module, you have
Uses of metal. Iron is used in manufacturing cars frames, bridges, doors, and lamp posts. Aluminum is used in manufacturing cooking pots, and foil paper. Copper is used in manufacturing statues, coins, and electric wires. Gold is used in manufacturing jewels. Uses of nonmetal. Carbon, graphite, is used in manufacturing positive poles of dry cells, batteries. Thank you.